Yeah, so hello guys, good evening. Am I audible to all of you? Yeah, hi Mahfuzur, Tanmay. Yes. Yeah, so guys, thanks for joining. So let's continue with our computer vision playlist. So today is day 18 and today we'll be discussing about how we can perform real-time object detections using YOLO V5. All right. Yeah. So yesterday I showed you how we can perform object detection with the help of detect on true. And there we used something called faster RCNN model, right? Faster RCNN model we used there. So today we'll be using YOLO. YOLO is a model also. So if you search for YOLO, okay, YOLO paper. So this is a like a research. So this is object detection model. The full form is you only look once, okay? So today I'll show you the practical of the YOLO, like how we can do object detections with this particular YOLO model. Okay, and YOLO also having the framework as well. Let me show you. So YOLO V5 GitHub. This is the official framework of YOLO from Ultralytics. Okay, so I'll show you the practical, and the next session I'll also talk about the YOLO theory, like what they have included in the architecture and why it is better than any other architecture. Okay, so everything we'll try to discuss. So the full form is you only look once unified real-time object detections. Okay, if you want to see the paper, just try to click here. Okay, so this is the paper, and YOLO having some variant, guys. So they initially proposed YOLO, then YOLO V2, V3, V4, like that. And today actually we have V5, V6, V7, V8, okay, V9, even V11. I think V12 is also there. Okay, YOLO V12. So that's how day by day they improved the model and they published, and we're using that for our task. This is the idea. All right. So first of all, let's try to see the practical how we can perform object detection with YOLO. Then I'll talk about the YOLO model. Okay. Yeah, you can see the benchmark of all the model. So see, we are having till YOLO 11. Okay, YOLO 11, and this is the benchmark. So the recent YOLO 11 model is better than others. You can see the performance is like very good, and you can see V10, V9, V8, V7, V6, V5. Then we also have PP YOLO, Demo YOLO, YOLO X, Efficient Det. Okay, so these are the model we have, and this is the comparison. This is the benchmark graph. Hmm. And trust me, this is super easy to use. Like only you just need a single notebook file, and everything you can do. It is better than, I can say, the Detectron. You can see like there were some installation process for the Detectron, but here it is like very easy to set up at the end and easy to implement. I'll let you know, okay, how it can be done. Yeah. So for today I'm using YOLO V5. I'm also going to show you how we can use YOLO V6, V7, okay, all the other model as well, so that you can choose any of them and you can perform your object detection task. Okay. Yeah, mostly all are same. At the end you just need to change some of the, let's say, syntax, some of the types. That's it. Hmm. So I already prepared a notebook, guys, for you to show you this YOLO V5 training. So this is the notebook. Even I'm also going to show you how we can, let's say, open up our web camera, okay, and how we can perform the object detections. Okay, each and everything I'm going to show you today. Hmm. And the dataset I'm going to use for this dataset, guys, I collected called sign language data. This is a zip file I updated in my Google Drive, and the link is also there. If you execute this code, it will download from my Google Drive. Okay, let me show you the data, how it will look like. Done. So now let's unzip the file. Extract all. So this is the data format, and I think guys you already familiar with this data format. This is called YOLO format data format. Okay. We already saw how we can annotate the data and save as a YOLO format. I showed you in my previous session. Please try to check it out. So it is having a folder called training. Inside that you can see I have the image. So this is related to sign language. So this is called hello sign. Okay. Then we have any other sign as well. Let's say I love you. Then we have no. Then we have yes. Sorry, this is please. Then this is thanks. And this is the yes. Okay. So that's how we are having some category. We are having some sign gesture. And this thing I collected with my web camera. Okay. So around 120 image we have for the training. And in the label, it is having the annotation file. This is the txt annotation file. So if I open it up, you will see some value. Okay. Numbers. And this number is nothing but the coordinate points. Okay. Coordinate points. And this is the label name. Okay. 0 means this label is coming at the first. Let me show you. So for this, you can understand this YOLO data.yaml file. Just try to open it up. So here, so this is a list, right? Name of the list you have in the data, the name of the classes you have in the data. So let's say hello is the first one. Now what is the index of the hello? 0. Okay, that means whenever you will see this 0, that means this is what your hello. Okay, hello, let's say sign coordinate point. Then next one you have I love you. So if you open the I love you image, sorry, I love you file, annotation file, so you'll see that this should be 1. Okay, this should be 1 because the order is 1 here. Okay, that's a no would be 2, please would be 3, thanks would be 4, and yes would be 5. That's why we are having six classes here. NC means number of classes, and this is the location of the image. So this information you have to keep inside data.yaml. Okay, and this YAML file we need for the training. Got it? So that's how you have the image folder. So one folder contains the image and another folder will contain the annotation file. Okay, and how to annotate the data with the help of RoboFlow platform, you can do it. And whenever you want to save it, try to make sure you save as a YOLOv5 format. Okay, yeah. So once done, you can upload your upload your data. Just try to make a zip file. First of all, make a zip file and upload your data to where? Upload your data to your let's say Google Colab, or you can also upload in the Google Drive. From there we can download the data and we can do the object detections. Okay, yeah. So first of all, you have to connect this notebook. I'll share the notebook guys in my resources section. So since run type, I'll use T4 GPU and let's connect the notebook. Okay, let's copy it first of all in my Google Drive, then I'll try to do the testing. Okay, got it. Now let me just connect the notebook. Yeah. After that, if you want to check your GPU, so this is the command NVIDIA-SMI. So this will show you your GPU we are using. We are using Tesla T4 GPU. All right. Now, the first thing we have to clone the repository of the YOLO. Okay. So how to clone? So I think this is the repo you saw. Click on the code, copy the link address and write this command git clone and paste this particular link. Okay. So once you done it, if you execute, it will clone the repository. Okay, you can see it's clone. Now if I refresh, so see YOLO v5 is there. That means the repo we saw it is completely cloned here. Okay, now the first thing, guys, what we have to do, we have to set up the requirements, because there is a requirement.txt file is there, and inside that we have some packages. So these are the packages we have to install. So let's do it. For this, I'll first of all go to the YOLOv5 folder, because this is a folder, right? And currently we're inside the content directory. Now if I go inside YOLOv5 and if I show you the project working directory, I'm inside YOLOv5. Now I can install this requirement.txt, and this is the command for that. So after installing the requirements, I'm also printing the torch version actually we have here. Okay, why we need? Because let's say if you want to set up in your local machine, okay, that time make sure you install the same PyTorch. Got it? So that's why we are printing all of this information. So training, try to do it on Google Colab if you don't have GPU. But whenever, let's say you want to do the inference, that time you can also do on your local machine, that is on your CPU machine, it will work. And YOLO is like very lightweight model. Okay, it can perform real-time detection with a very low latency. And if you see the model, so let me show you the model of YOLO. So here they are having the section called model view. See, so this is the pre-trained checkpoints they are having. Okay, so YOLO VN, VS, M, L, X, okay, N6. So this is the model, and this is for the detection model, I think. So here they have written YOLO train on Coco dataset. Okay, and this is for detection. Okay, you also have segmentation model and classification model also, which I will also show you later on. Like YOLO also having some other variant. You can also perform the segmentation as well as the classification, but YOLOv5 it is only for the detection. Okay, detection purpose. Now you can see N means this is the nano model, S means this is the smallest model, M means this is the medium model, L means this is the large model, X means this is the X large model, N means this is the little bit bigger than this model. Okay, that's how it is having all variants of model of YOLO. Okay, and this is the size of the model, pixel size, that means input size. This is the MAP score of the model. This is the MAP score at 15. Then speed on CPU, speed on GPU, speed on another GPU. Okay, and the parameter size of the model, flop of the model. Okay, each and every information you will be find in this particular table. Okay, now based on your, let's say, interest, based on your task, you can select the model. Let's say you want to do more task which you need like very let's say fast response from the model. That time go with a smaller model, because this model has a smaller size with a faster inference. Okay, faster inference time, but accuracy would be little bit less here, definitely. Okay, but let's say you are working in the medical domain and you need higher accuracy instead of speed. That time go with bigger model. And then the model is big, MAP score is also big. Okay, and the speed is also a little bit slow. Okay, so in medical you don't worry about the speed, you only worry about the accuracy. But in other sector, let's say you want to do real-time traffic detection, pedestrian detection, okay, that time go with a smaller model. And if you see, the smaller model is also powerful. Most of the tasks you can solve. Even if you have a smaller object present, you can also detect with the help of this YOLO. Okay, so yeah, this is amazing like model you can use. And overall they have created an entire framework, guys. Okay, at the end they have created an entire package for you, so you can only clone this YOLO v5 and do everything. Okay, whatever you need. Yeah, so you can see, guys, my installation is complete. Okay, and this is the PyTorch version we are using, and some other library as well. Okay, fine. Now the next thing, I just need to download the data. For this I will again get back to my content folder. So you can see cd content, and now to download the data from my Google Drive, guys, I have to execute this particular code snippet. Okay, so what you have to do, let's say in the Google Drive, first of all upload your data. So let's say if I open up my Google Drive, let me show you how it can be done. Let's say this is your Google Drive. You have something inside that. Let's say data. Let's say you uploaded this data. That's a sign language data you uploaded this zip file. So what you have to do, just right click, click on share, okay, and make it anyone with this link. Okay, initially it would be restricted, but you have to make it anyone with this link. And after that you have to copy this URL. Okay, copy this URL, and this URL you have to provide here. Okay, make sure you are giving your URL whenever you are changing your data. But as of now, if you don't have the data, you can use my URL to get the data. Okay, and to download anything from the Google Drive, we can use gdown package. So let's import gdown, and this code will try to download this data from the Google Drive itself. Okay, so see, it is getting downloaded right now. And if I refresh, so see guys, my data is downloaded, sign data zip file. But again, it is a zip file. I have to unzip the file. How to unzip? This is the command for that. Unzip sign data zip. Now if I execute, it should unzip. Now see, whatever files and folder I had inside that, everything is available. So this is the training data folder, this is the testing data folder, and this is the data.yaml file. Okay, yeah. So very clean and very easy way to do perform object detection if you're using YOLOv5. Okay, now if you want to see anything, let's say I want to see the content of data.yaml, I can use the cat command, cat data.yaml. So whatever content we have here, it will try to show me in the console. Now first of all, I have to extract the number of classes, this parameter, because we will be using the pre-trained model, and pre-trained model is already trained with Coco dataset. Okay, I think you know object detection is trained on Coco dataset, and Coco is having 80 classes. Okay, 80 classes, but here we are having only 6 classes. So this number of classes we have to change, guys. Okay, if you want to use the pre-trained model, the configuration file you have to change with this number of parameter. So for this, we are extracting the NC classes from the data.yaml. So NC value is 6. Okay, initially it is 6 because we are having 6 classes, and this is the configuration file we'll be using, guys. So here, sorry, so here if you open the YOLOv5, inside that you have something called model, and here is the model configuration. Okay, now based on your configuration, guys, whatever model you want to use, let's say I want to use this YOLOv5s model. Okay, so this is having a YAML file. So YOLOv5s model, v5s. So see, this is the file. Okay, now if I open it up, you'll see NC parameter is equal to 80. We have to make it 6 because we are having six classes. Okay, in our data. Otherwise everything just keep it default. And this configuration file will try to download the model. Okay, the pre-trained model. So let's do it. For this, first of all, we are seeing the content of this YOLOv5s, this configuration file, with the help of cat command, and we can see NC parameter is equal to 80. I have to change that. So to change it, guys, you have to first of all import this magic cell. Okay, and whatever content you have inside this file, try to copy everything and try to paste it here. Okay, only the change you have to do here. So you have to give this particular bracket and the number of classes variable, the variable we have set here. I think, remember, number of classes, this variable. Okay, so what will happen, whatever number of classes you have, it will be replaced here, and this particular file would be saved again in a different name. So now right now we are saving as a custom underscore YOLOv5s.yaml. Okay, so any prerequisite for this course, any basic knowledge of to follow. So the prerequisite wise, you need Python knowledge and basics of machine learning. Okay, Tanne. Okay, that's it. Otherwise, you can go through the entire playlist. I think you will be able to understand. Yeah. So now you can see this is the changes we have done, and if I execute, so it will create another file here. So refresh. So see, custom underscore YOLOv5s.yaml file created, and right now the NC parameter is equal to 6. Let's open it up. See, right now the NC parameter is equal to 6. Previously it was 80. Okay, now we have made it change 6. So this is the small change you have to do. Now let's say you are using M model. So make sure you are doing for this particular file that time, this content that time. Okay, just open it up, copy all of the content and replace it here. Now we are ready for the training, guys. Okay, now how to start the training? This is the code for that. So in YOLOv5, we are having a file called train.py. So what Ultralytics does, so they have already written all of the training code. Okay, you don't need to write anything, you don't need to change anything even. So keep it as it is and start the training. Only just need to pass some parameter. So we are executing the train.py inside YOLOv5. After that we are setting the image size. So if you say see the image size, okay, the mostly image dimension would be 500 around, and we are using the small model, right? So small model, when they train the model, they are using this particular size of the image. That's why we are providing this size. Then the batch size, okay, batch size you can change based on your machine configuration, number of epoch you want to train. So I want to train 100 epoch. You can increase and decrease based on your requirement, but whenever you are doing the actual training, you have lots of data, make sure you increase the epoch. Then you have to give the data.yaml file path, so which you have here, data.yaml file path. Just try to copy the path, okay, copy the entire path, you can paste here. Otherwise you can give / data.yaml. So what it will do, it will get back this folder and will try to find the file here. Then you have to give the configuration file, the configuration file we generated, where it is. So in the YOLO model, so this is the configuration file. Just try to copy the path and mention it here. Okay, then you have to provide the weight name, like the model you want to use. So here I want to use YOLOv5 as model. That means this model. Just copy this and at the last just give .pt. That means pt is a PyTorch model, okay, PyTorch format model. That's why you are giving pt, and we are giving the output folder name, which is YOLOv5 results. Okay, so that means whatever whatever artifact it will generate, it will save inside the folder. Now let's start the training. So I'll execute the code. So it will download the model. After that, load the model, then start the training, and all the logs would be saved in the YOLO folder. So it is telling enter your choice. Do you want to use 1 dB? So I don't want to use 1 dB. So what I will do, I'll just try to give 3 here. Don't visualize my result. Yeah. So now I think it will start. See, downloading the model. Now see, epoch started. Okay. So 100 epoch it will train. So let's wait. And you can see the log, like class losses, everything you can see. Hmm. 22 out of 100. So any question, guys, still here? Let me know. On Raspberry Pi, would you use YOLO or any other model? Currently, I don't have Raspberry Pi with me, Matt. Okay. Maybe in future video, I'll show you like hardware integration, how it can be done. See, it is also easy if you are using Raspberry Pi. Then it's a computer only, so you can install the operating system there. Mostly people install Linux, and inside that, you just need to set up the Python environment, and you can execute the code after installing all the requirements. Either Raspberry Pi, either you can use Google Coral, NVIDIA Jetson Nano. So some devices are there, you can use it. So still training is going on. And if you refresh here, so see, it will create a runs folder. Okay, inside runs training YOLOv5s results, see all the artifact would be saved here. This is your weights. Okay, base.pt, this is your training model, and here you have some metrics as well. I'll show you. Okay, this metrics. Okay, so my training is completed, and here you can see all of the MEP score for all the classes you have here, and all of the MEP score are close to each other. That means my learning is great. Okay, and here it has saved my model in the weight folder. So this is the model, and some of the metrics it has also given. Okay, now let me visualize some of the metrics and show you. You can also start TensorBoard to see the logs. So this is the log from the TensorBoard, but this is pretty small. Okay, so let's see something meaningful. So there is a file you will be getting called result.png. Okay, so here in the runs folder YOLOv5s results, so here you have the result.png. Okay, this image, so this image has already all the loss and accuracy score. Okay, so let's try to plot it. And how to plot? So we are using utils.plot, and we are giving the location of the image. So just try to copy the path, okay, and paste it here. Now if I execute, so it will show the image in my console. So see, this is the image, and this is the training box loss. That means as per my epochs is increasing, loss is also decreasing. Again, the object loss is also decreasing, class loss is also decreasing. Okay, box validation box is also decreasing. Validation object loss is also decreasing. Okay, that's how you can see my learning is pretty good. And this is the MAP score. Okay, MAP score, precision, recall, I think we already discussed this part in the theoretical class, right? So see, as per my epochs is increasing, MAP score, that means my precision is increasing, recall is increasing, then MAP is also increasing, and MAP 0.5 to 0.95 is also increasing. Okay, initially there is some zigzag issue, but later on you can see it got fixed. That means I can say my learning is good, guys. Okay, my model has learned something here, and this score should be close to 1 accuracy, and loss should be always close to 0. This thing you have to just think, take care. Now if you want to see some ground truth data, so for this you can see some batch images. So you also have some batch images generated by your YOLO. So these are some batch images, guys. So this is the original level we have here, and that's how I have annotated all of the images. Okay, and these are some augmented data. Augmented data means YOLO v5 internally does some augmentation technique in runtime. So you can see some of the images got cut, some of the images changed the color, some of the images you can see got black and white. So this is called augmentation, guys. Okay, so they perform the runtime augmentation and they increase the data just to make my model more robust. And once everything is done, now we can do the detection, and this is the detection code. So in the YOLO folder, we are having something called detect.py. Okay, this file, and again Ultralytics written everything inside this file. You don't need to change anything, only need to execute and give some parameter. So here you can see we are executing detect.py. We are giving the training weights. So where is my weights? My weights is having inside runs train YOLO results and weights. Okay, inside that, this base.pt, just try to copy the path and provide it here. So this is my training model. Again, the same image size I'm giving, the image size I used during my training, and the confidence score. Like if my model is 50% confident, then it will be able to detect, okay? And the source images I'm giving my test data, test images, okay? So this particular path I'm giving. Now let's try to test my model. Now let's see whether it is able to detect or not. If you have a single image, guys, you can create a folder, and inside that you can keep a single image, okay? Otherwise you can also give the direct image location. Let's say you are having an image doc.jpg, or let's say hello.jpg. Just try to give hello.jpg here, okay? And if you have a video file, you have to give the video location. Let's say you have a video file called test.mp4. Just try to give test.mp4 here, okay? That means image video. If you have image and video, you can give as it is, the same name, okay? And if you want to open up your camera, you have to give source is equal to 0 that time. But this code will not work in the Google Colab, because Google Colab is running on the cloud. It can't access your local camera, okay? If you want to access your web camera, guys, you have to set up this YOLOv5 in the local, okay? In your local. And how to set up? The same way we can set up, guys. The way I set up this YOLO in my Google Colab, first of all, I clone the YOLOv5 repo, and after that I install the requirements. The same way you have to do. First of all, create a virtual environment of Python, install clone the repo, install the requirements. After that, execute the same command, okay? And give source is equal to 0. So this will open up your camera, okay? So as of now, we are using my test image folder. Done. Now if I show you my detection, so it is available inside the YOLOv5. Runs, detect, experiment, and see the first images. So see, it got detected hello with the confidence score 0.87. That means 87% confident this particular gesture is a hello. So this is correct, guys. So I think this is a correct one. Now let's see another one. So I love you. So this is what I love you, but this is not got detected. So let me open another one. So see, this is got detected, okay? I love you, 76% it is telling. Now here we also have no. This is called no, 71% confident. This is please, 0.94, that is 94% confident. This is thanks, 83% confident. This is yes, 80% confidence. That means all the detections are correct, okay? My model is able to detect this kinds of gesture, okay? This kinds of sign language right now. But initially it was not able to do, because it was a pre-trained model, and pre-trained model doesn't have this kinds of sign gesture. So we just picked a pre-trained model. On top of that, we trained our custom data, okay? And we make this model to the sign language detection right now. Hello bro, I came from your MLOps course of 12 hour. Thank you so much, Wonder. I hope you enjoyed that MLOps course. Now you can start this computer vision if you want. All right. So this is how, guys, we can train, custom train our data, okay, with the help of this YOLOv5. So v5 is a model as well as the framework, okay? In my college, I have learned C language and currently learning DSA. Is your course good for the beginner like me? Definitely, okay, you can check it out. Yeah. So I'll also show you how we can create the web app, guys. But today I'm not going to show you how we can create the web app. That time I'll show you the local execution part. But if you want, you can set up in your local machine, and you can open up your camera. Okay, right now I'm using my camera in my YouTube studio. That means currently I'm doing live. So if I start my camera, it will not work, okay? So that's why I'm not going to show you the camera today. So maybe other class I'm going to show you how we can create the web app like user app, and there I will also show you how we can launch up our web camera to do the real-time detections. Okay, yeah. And till then you can also set up this part in your local machine, this setup. MLOps means machine learnings plus DevOps, right? Yeah, we call it as a ML ops. Yeah, mostly this MLOps comes from the DevOps part. Wonder. Yeah, so guys, I'm going to share this notebook in the resources section. From there you can download and execute from your end, and let me know if you face any issue. So in the next class I'm going to discuss about the theoretical understanding of YOLO, and I will also show you one class there. I will try to do the local setup. Okay, local setup will try to create the web app, as well as I will also show you the real-time web camera execution. Okay, how it can be done. So yeah, so this is all about, guys, from this session. I hope you got it, how we can perform real-time object detection with YOLO v5, and it is super easy to use. I think you already know that. Now pick up any kinds of data. If you have your custom data, try to use RoboFlow platform to do the annotation and make some amazing project, guys. Okay, and please tag me also if you are sharing this thing in the social media. I would like to look into that. So I think, guys, we are done. So if you have any question, let me know. Otherwise, I think we can conclude the session. Let me know, guys, if you have any question, and please hit the like and hit the subscribe as well. If you are new to my channel, hit the like and subscribe as well, guys. Okay, so thanks for watching, guys. Good night.